Your brain recognizes 7 plus 7 instantly, yet there's a slight cognitive stutter when faced with 8 plus 7. We have a natural preference for symmetrical addition that we can use to our advantage. This symmetrical 4 plus 4 pattern on a domino acts as a mental anchor. For numbers separated by just 1 or 2 digits, we simply look for the nearest double. To solve 4 plus 5, we solve the double we already know. 4 plus 4 is 8, and then move one step up. The secret is to mentally pocket this leftover value while you handle the main calculation. It stays separate for a moment, then gets added back to complete the total. This isn't a shortcut for easy problems. It's the foundational building block for advanced mental math. We are bridging the gap between what the brain finds difficult and what it finds effortless. We can scale this same logic up to multiplication. Multiplying 346 by 4 is best handled as a successive doubling, or a double-double. Doubling 346 gives us 692. Doubling that second result brings us to 1,384. Division presents a different hurdle, particularly odd 10 numbers like 38. That 3 in the tens place doesn't divide cleanly, often causing the calculation to freeze. To solve it, we round up to 40 and subtract 2. Now, having both parts is simple. 20 minus 1 gives us 19. Shifting numbers into these friendly boundaries removes the cognitive friction of odd number division, maintaining a steady pace through the problem. Consider a pair like 16 times 35. We can visualize this as a geometric area with a height of 16 and a width of 35. By cutting the even number in half to 8, we can double the other number to 70. We're simply moving the mass of the rectangle from one side to the other. The total area, the answer, remains exactly the same, but 8 times 70 is a far easier calculation to hold in your head. Strategy matters. Having 18 to get 9 times 16 makes the math harder. Doubling 18 to 36 and having 8 to 4 makes the solution reachable. Take a moment to try this yourself. Pause the video and solve 45 times 24 using the halve and double rule. Doubling 45 to 90 and having 24 to 12 transforms the problem into 90 times 12, a final result of 1,080. Viewing multiplication as flexible geometry allows us to reshape these values like clay until they fit a solvable pattern. This strategy scales even further. For a problem like 25 times 16, we can use a chain of successive rungs to find the answer. Our first step is to double the 25 to 50 and halve the 16 to 8. We can repeat this immediately. Double 50 to 100 and halve 8 to 4. 100 times 4 is 400. The key to the chain is knowing when to stop. You don't have to reach 1. You stop the moment you hit a round target like 50 or 100. These 3 rules, near doubles, rounding through odd tens, and geometric halving, are your primary tools for high-speed mental math. Brute force calculation is exhausting. Mastery comes from recognizing these specific patterns and consciously selecting the path of least resistance.